Welcome to the webinar on the Big Data Future Social Mining Analytics Engine. We have organized this webinar in 2 presentation sessions, 1 live demo sessions, and 1 question and answer session at the end. So I am Massimiliano Assante, and I will be giving you a general introduction, and I will talk about the design principle of the service. And then Marco Lettere from Nubisware, who actually led the development of the service, would briefly talk about the architecture and its main functionalities. And then Giulio Rossetti from CNR, if you work in Big Data, you all know him. He leads the work package devoted to method integration in the Big Data infrastructures, and he will give us a live demonstration with method imports and execution example. And then we decided to have questions at the end. So if you have questions during the, let's say, the presentations and the demos, please write them in the Zoom chat so you don't forget, just in case. And in the Q&A session, if you want to also, when there will be the Q&A session, please use the raise hand tool, and you will have also the possibility to open your microphone and welcome if you wish, or just type your question in the chat. So before we actually start, let me give you some directions on where to find the social mining analytics engine in the Big Data infrastructure gateway. So you know that the Big Data infrastructure gateway is accessible on the sobigdata.d4science.org URL. Right after this webinar, we're going to make it available in the Big Data Lab vLab. So when you access the Big Data Gateway, you will land in this page, click on the Big Data Lab, and you will see that you will find the service under these 2 functions on the top bar. You will see that there is an importer tool and the actual engine tool. You will find them over there. There is also an how-to with the documentation that is already available in the Big Data Lab. And in the Big Data Lab, you will also find this presentation under the shared folder Method Engine Webinar 27 March 2024. So if you want to download the presentation right now, you can also do it. So let's start by talking about what is the new social mining analytics engine in a very nutshell. First of all, the service name is Cloud Computing Platform, or CCP, and I will be referring it to as CCP in the next slides. So it is a user-friendly data analytics platform with on-demand and scalable computing resources on the cloud. It allows you to import and execute methods on the cloud, but also to collaborate by sharing not only the methods, but also the method executions, their inputs, and the result with your colleagues. So in designing the service, we really took in account the collaborate, let's say, feature. In fact, the service tries at least to foster better collaboration and to enable the teams to work together from anywhere with an internet connection and access to the same data and application. CCP is built upon the experience of the previous D4Science data miner engine that has been the social mining analytics engine of Big Data since more than 5 years now, probably. But CCP uses a novel approach that is based on containerization, REST APIs, and JSON. So what are CCP main features? it offers a per method web user interface and REST API access via standard. And I will be talking about this, the standard in the next slides. It offers the possibility to import your methods with a dedicated tool that supports any programming language, but also offers a number of already available, so out-of-the-box methods as a service that you can run by accessing the method engine. And we also, it also supports automatic code generation for Python, R, Julia, and IPy notebooks. This means that if you find a method there that you like and you would like to integrate it in your Python script, in your Python program, it also give you the generated code that you can import automatically. And in doing this, it takes care of the provenance. So any method execution performed in the CCP automatically store provenance information. I will touch also these points in the next slides. So how does it work? You arrive with your method that can be a script, an algorithm, a software. There is an importing phase with a method editor that use Docker images. And then after you specified your input parameters, the result in the import process, the result of your method will be an automatically generated web user interface with the possibility for user to enter their method and run your method on the cloud, on the method engine. And also the possibility to see live the logs of the execution, but also your method becomes a sort of web service in the sense that it will be executable also programmatically by with web APIs that will be made available for its execution by the engine. Some notes about these method executions that are maybe not, let's say, immediate. Whenever an execution is performed in the social mining analytics in the CCP, so in the workspace, a CCP folder is automatically created. You can see here in the slide, in the workspace, in my workspace, actually it's Andrea's workspace in this, but anyways, in your workspace there will be an executions folders under the CCP folder that will be automatically created by the service, and for each execution you will find a subfolder in the execution folder with all the output and the metadata about the execution. And not only that, each execution you can decide, maybe it is a long-lasting execution, so you will also receive a notification in your inbox when it finishes, if you like. And as I said before, you can also launch method executions programmatically. This is because we provide a code generation tool for the execution that you can import, and also because we use a standard for running the processes from basically any programming language. Let me briefly talk about the provenance management that CCP does. So, provenance is the lineage and processing history of research data products and the record that, of the processes that led to it. So CCP, for each execution, store a Provo XML file automatically in the workspace together with the execution. what is the Provo ontology? So it is Provo is an ontology that expresses the Provo data model using the OAuth2 web ontology language. And in this slide here, if you can see, there is an actual example of an XML generated file where you can see, for instance, the start time and end time of execution. You can see the infrastructure, the computation. You can see the user that ran the computation is prov person, and you can see the operator name that in this case is the method name, simple image classifier, the versions, and other data. Now I've put these slides to briefly talk also about the differences between the previous and this next social mining analytics engine. So the previous service was called Data Miner, and then the new one is called Cloud Computing Platform. So what are they share the same design principle, but what's the difference? So in terms of virtualization, Data Miner used to use virtual machines, whereas CCP used containers and isolated runtimes. In terms of executing cloud infrastructure, this was selectable by the, say, VRE managers in Data Miner. Now in CCP, we have taken a step forward in the sense that at import, import phase, during the import phase, the author can select on which cloud infrastructure she or he would like to run to execute the method. So, in So Big Data, we're going to have different sites spread all over Europe. And potentially, if you know that there is an typical cloud infrastructure that would, fit your algorithm better, your method better, you can select it during the method import phase, and the engine would automatically run the computation on that site for you. In terms of standard protocol and HTTP APIs, Data Miner used the OGC WPS, which was based on XML. CCP used the OGC API processes that is based on JSON and is based basically the evolution of that protocol. In terms of method integration and method development, Data Miner had its own importer called Software Algorithms Importer with some GitHub support. CCP has its importer, of course, and during development, you can use your IDE with any CVS support, so with any code version system, so Git and CVS. So in this sense, this should be easier for you, and we hope it should be easier for you. In terms of methods availability, numbers of methods, Data Miner had many, of course. It has been with us for many years. CCP is new, and fewer are available, methods are available, but please let me take this occasion to thank the authors of the previous methods in So Big Data and Marco Lettere that they worked during last part of 2023 to let's say migrate the methods that were in So Big Data Lab Data Miner to the cloud computing platform. So you will see that the method that they were present in Data Miner will be also present in the CCP now. In terms of Jupyter Lab and RStudio integration, Data Miner had support because of the protocol, but you will see that now it is much easier because we provide the code for you. In terms of front-end technology, CCP use, let's say, web components, and it is exportable on multiple code management systems. This is my last slide. Now after this, I will give the floor to Marco, but let me underline that we have built this service with trying to support also and to encourage open science practices. So how does CCP support open science practices? Of course, it uses digital technologies, and we have implemented some collaborative tools. You can see that you can share a method, you can share an execution with your colleagues, you can repeat your execution, and you can reproduce also the method execution. CCP enables the reusability not only of the outputs, because they are stored on the workspace and can be shared, but also of methods. So because of the standard for process execution that we use, and in general it aims to improve the transparency and ways of disseminating knowledge. So now I think Marco will give you, I will stop the sharing and Marco will share and will present a technical overview of the service.
Okay, I won't introduce myself because Massimiliano already did. Thank you. Let's go ahead. We worked together in the last 3 years with the CNR staff and in particular D4Science development team in order to build this new CCP software. It has been hard work for 3 years with an initial phase where we had a lot of presentation interviews. Massimiliano, you remember we had talks for hours and hours discussing on what already was there. And I mean, it's a very long experience that D4Science has matured on top of the argument of computing engines. Out of this first phase, we have drawn 10 abstract use cases, so that they could drive the development, the analysis and the design of the CCP. And this has led to, let's say, a sound and logical architectural model. During this phase, we already started developing, so the development of the CCP went on in an agile way, let's say, with early prototypes and the first test performed by team members of the D4Science team very early. At the end, the main objectives, I think, have been achieved, which were actually to embrace heterogeneity in the sense that we had to support as much as possible. And when I say as much as possible, I mean services, languages, libraries, everything. But keep the software manageable. So the software should be easy to provision and easy to maintain. And this is another core principle that somehow clashes with the original aims. So the architecture looks like this. I won't go too much into detail because we can discuss this with technical people if they like in the question and answer section. But anyway, the CCP is let's say a network of services that could cooperate together. There are the front-end services. Are you able to see my mouse cursor if I move it like this?
Yes.
Okay, fine. So there are front-end services which actually export user interfaces that interactively expose features that the users can use, features which are actually meant to be management of methods, execution management, requesting execution of methods, and so on. There is a workflow orchestrator that manages the complex workflows and processes that all these services cooperate into. And most importantly, the controller API and the controllers, which are actually the real distribution part of the cloud computing platform of the CCP. Because the architecture aims at being able to integrate computing infrastructures which are distributed and heterogeneous. And this is achieved by installing, let's say, what we call controller on top of the infrastructure that will contribute to the overall CCP execution environment. And they communicate with CCP through a dedicated and secure protocol. I say secure because identity and access management is transversal. is orthogonal to all these functionalities. So it has been taken into account from the beginning in order to be to secure pervasively all the interactions among these services. What is a computing infrastructure? Mainly, you can imagine a computing infrastructure to be some kind of hardware with the operating system and everything that is needed on top of it to run methods. And it can be a cluster with several hosts. It can be a single host infrastructure, whatever. It just has to advertise itself through the controller and accept execution requests from the CCP. This is, logically speaking, the overview of the architecture. This translates also to physical architectures, and which is the current state of the CCP. There are actually, let's say, roughly speaking, 4 infrastructures available. The D4Science production infrastructure, which is the one you will run your methods on, and it is based on Docker Swarm, so it is able to execute methods encapsulated in Docker containers. We have also a development infrastructure that we use for testing. There is another infrastructure which is more experimental and where we try also different technologies besides Docker. For example, we have already experimented with success using LXD containers, and we plan in the future to increment the possibility of embracing also other technologies for encapsulating methods. Another infrastructure is my laptop, and this is just demonstrates the fact that it is not necessarily that you need a data center for running methods, but if your method is compatible with a PC, with a laptop, and so on, and you have one such infrastructure, then you can also run methods on top of a custom hardware. Of course, you won't have to deal with this infrastructure. You will have only one infrastructure to choose from at the moment. The Sobig Data community. So the choice of infrastructure will be a no-brainer for you, but we are already working on other proposals that will introduce intelligence and everything that is needed to probably suggest the use of different infrastructures depending on data locality and how Massimiliano told. Actually, there will be a logic behind the choice of infrastructures, and we are working on this. Okay, what happens to a method? The execution of a method is actually, let's say, a workflow. So I decided to design it with a workflow modeling language. It starts from a user requesting the execution of a method through an HTTP request, which adheres to the standards of OGC processes, which is actually the evolution of the WPS into an API which is based on REST and JSON. So the workflow in that case accepts the method, enters this launch phase, and then starts with the single steps, which actually consists of the deployment of the method on top of the infrastructure that has been associated with the method. Then the execution phase, where the actual execution of the code that the method consists of is performed. Every kind of error that arises in this workflow, and this could be because of several issues that can arise, will be handled, and either if the method complete correctly or the method complete with errors, there won't be, let's say, traces of it in the infrastructure. The workflow automatically cleans up your execution and frees resources for following users and executions. After the execution phase, which can be kept by a timeout, so you can, there is currently a timeout set, but you can also define a timeout for your method. So you can decide to terminate your method after a given amount of time. And this is handled as an error condition. You see it here from this timer to the error management. After the execution, you enter a fetch phase where actually your outputs are grabbed and pushed onto the repository of the executions. And then there is a undeploy and destroy phase, which you can imagine to be a single phase actually for the type of architecture that we have now. Okay, a few words about the concept of runtimes and methods, which you will probably encounter also if you read across the documentation Massimiliano provided the link to. You can imagine the execution, a runtime and the methods to be something that is supported by a hardware. So runtime typically is the part that consists of an operating system, operating system specific libraries, and maybe a programming language runtime, you can, for example, Python runtime or Java or Julia or whatever. Okay. On top of these, there is the methods, which actually usually contributes with some application code and application dependency. In order to execute it, you then have to instantiate these and pass inputs to your method. Okay, so this is usually what is built when you take a bottom-up approach and you try to distinguish between what is the runtime and what is your actual application or method. An example of this may be from something like you have a runtime consisting of an Ubuntu 2022, 22.04. You have Git and CUDA installed on top of it, and the Python 3.8 runtime. Then your method contributes some code which it fetches from a Git repository together with some configuration files, for example, and maybe it uses also some library like PyTorch. And then with the inputs, you can run this method. What is the power of using containers in this case? It is actually possible that you can go to Docker Hub, for example, to some kind of publicly available Docker registry, and you find some kind of container which already provides a lot of what you would have to do to prepare your runtime. For example, there is a Docker container on Docker Hub which already comes with all the operating system, Git, CUDA, Python, whatever is needed. So you won't have to bother with installing this kind of software because it already is provided by a runtime you already found on top of a registry, and you just have to provide your method with the code and your dependency. This way of working, let's say bottom up, contributing progressively some information and keeping the possibility of changing and swapping these boxes, these levels and layers, is what we actually call experimentation, because it helps you in saying, okay, I made my method in this way. Okay, I will try to use another library. I will try to switch to Python 3.9 or 3.10 in order to see if everything works. I fix some code on my Git repository and then just make the method run again and it fetches its code during execution. And so you can work in a very flexible way, and you can experiment until you get to, let's say, a stable condition for your method. There is the other way around. Once you have a method built up like this, let's say we start a process called consolidation. This is something that says, okay, now that you have a stable version of your tool, compress, squeeze everything down, and make the concept of method and runtime actually the same. Okay, so in this way you get something which is immutable, something which is really replicable and redoable without having to bother about the fact that maybe someone has changed the version of a library, or someone has updated the runtime with a different operating system, or anything like that. At that point, you can freeze everything into a new image. This is the name that we give to a container that is somehow already pre-built and pre-configured. And you can call it, for example, I use it here, Docker naming conventions. So the user / the name of the container and a version. So for example, you could just name this to be my method version 1, or my method version 2 or something else. So for example, version with CUDA or something like that. This is called consolidation because this actually makes your method completely immutable and fixed. So it won't be possible to change it, and you can repeatedly execute it just by changing the inputs and being sure that everything will be kept as it is. As an example, I took the UI element that configures a method, and you can see the left method is something named Python test or something like that, which is actually something very experimental. The right part is a method that is currently available on Big Data, and it is a consolidated method. So for the first difference is you see in one, we start just from a runtime that has only Python 3.8 installed, probably a bare operating system plus Python. In the other one, we have a very specific name for the container, for the runtime, because it is actually exactly the one that contains everything that is needed to run my consolidated method. Then you have the script that says how to deploy the method. In the experimental one, you can see a lot of lines, because we do a lot of things while deploying. We pull the Git code, we install the dependencies, we create directories, and all those kind of things that typically won't be necessary in a consolidated method. And in fact, you see in the consolidated method, the deploy phase only consists of downloading an input file. So only inputs are provided. Another difference is in the fact that maybe the runtime that you use for the experimental method, for that one, you don't even need a Docker file. So a file that says how the runtime is made, because you just go and get Python 3.8 from Docker Hub. On the consolidated method, it's different, because there you have a recipe for your container, which already performs a lot of things. For example, installs dependencies, creates directory, runs, for example, here pip install in order to set the application dependency, already clones the code and fixes the code inside the container, and so on. So this is mostly the difference that you can see. In one, you go with a lightweight starting point, and you build everything in the deploy and execute phase. In the other one, you have a more complex entry point, let's say, but what you do in the deploy and execute phase is much simpler. Okay, quickly to the interfaces. I will be flying through this because Giulio will show this live. So in the first phase, for the method definition, you have a list where you can select methods from the available one. Available means yours, where you are authors from, or where you are authors of, or because they have been shared in your community, in your VLab. You can also share methods from here with your community if you are authors. Then you can create, edit, clone, derive methods in this with this other interface, which is the method editor interface. The methods are actually JSON documents according to the OGC processing to the OGC processes model. And you can define a lot of metadata, categories, tags, authors, whatever you need. Then you select the infrastructure on top of which your methods is planned to be run. At the moment, you have one, as I told, to choose from, and the algorithm is very simple. It just chooses the first infrastructure that you select. As I said, we are working in other proposals in order to make this much smarter. Then you select the runtime you want your method to run in, and it could be some simple runtime, and then you provide a lot of scripting in the deploy and execute phase, or a complete runtime for a consolidated method, and then you will probably need just to say what are the inputs and the outputs, and a very small script for the main lifecycle phases, which are actually deploy and execute. Currently, the undeployed phase is not scriptable because it has no meaning in this architecture, because at the end, everything is destroyed because it is inside the container. So deploy and execute scripts are the only phases that is meaningful to be scripted. Okay, very quickly, there are a lot of inputs that you can select from, choices, integer, dates, whatever, secrets, where you can share secrets, and they are encrypted end-to-end from your user interface down to the container where that runs your method. There is support for array. There are also special inputs that you can use. CCP image is one of those, and it actually says what is the container image that you want to use, as I told before. There is a CCP node that it can be used to label executions afterwards in order to find them better among all the executions that you will probably archive on your workspace. And there is also the possibility to change the timeout of your method if you plan to if you plan to use one that is less than the current default, which is actually 2 hours. Output specification is mainly meant for documentation and for provenance, because you will see during the execution outputs, you can fetch everything that is just stored in a particular directory. So the outputs that you produce are not meant to be constrained by this definition, but this definition is only documentation. And as I had said, only deploy and execute phase are currently scriptable. Okay, for the method execution, there is the same list that you saw in the other slide, and here you can again select a method and either drag and drop it on top of the other interface, this one, or click on the play button in order to instantiate it in this form, where you can specify the inputs, the values for your inputs, sorry, so that the values that will populate your execution request. You can monitor the execution in real time, so you can see the status advancements of the method, the infrastructure that has been chosen, the runtime type, and also standard out and standard error logs that appear live while you are looking at the screen. You can request the execution once you have compiled all your inputs, and this can be done either by clicking on an execute button or by generating programmatic code that will execute your method in a programmatic environment, such as, for example, your Python application or your notebook. Execution can be archived to your workspace, or only outputs can be archived. So, for example, this is a small difference, because if you archive executions, then as Massimiliano told, all the provenance information and everything is kept together with your execution, and is there. You can also just say, okay, I want to archive only the outputs of a method, because the outputs are used from my workspace by another tool in order to produce something else. So this is for favoring, let's say, workflows that share data among different things, different executions. You can, as I said, generate code for programmatic re-execution of a method. So the difference between the first one that I showed before is that you want to execute a method and you say, this is my input, and you can execute this programmatically. But you can also say, okay, I want to re-execute exactly this execution. So I don't bother with providing you the inputs and everything, because you already know, you just re-execute. And this is also performable either from the graphical user interface or programmatically. And you also have a direct link here that if you click, you will get into this graphical user interface with all the things already prepared and populated, in order that you just have to click on the execute button and re-execute. This is useful, for example, for sharing the execution with colleagues, or for using it inside the publication in the catalog, for example. A few things to the executions. As we told, the D4Science platform currently runs Docker containers as methods. Your container, you can use every publicly available registry in order to select images to start or to run from, including an experimental D4Science registry, which is hosted directly on the D4Science premises. Your methods is fed with some environmental variables that can be used to ease authentication when you have to interact with D4Science services. And they are mostly environmental variables used for getting tokens and authorizing your code. There are also a few more variables that can be used in order to identify an instance if you have multi-container methods. This is also possible, even if yet experimental, even if still experimental. There is a special folder for your methods, which is named /ccp data. Whatever you write in there is packaged and put together with your execution as outputs, okay? So the size is limited here. So it is not meant to be something where you produce gigabytes of data. This is meant to be for something like you produce a JSON output, okay, it can be put there. You produce a CSV, which has a few hundreds of lines, you can put it there and so on. Please use the workspace in order to share larger files, huge files, and then you, as an output, just produce the link to the data set. In the execution, there are also a few more things that probably you won't they are not generated by you, but they are kept there for debugging purposes. So if you have problems with an executions and you share the executions with us, with the development team, from that kind of information, we can try to reconstruct what happened. And if there are strange errors, we will try to find out and fix them. As a final remark, please consider good housekeeping. So executions that you see here on the right part of this slide are meant to be volatile. So they are kept in a storage which is close to the CCP. So you can imagine it to be a sort of cache. If you have, you can delete executions that have failed or that are useless or that have no value for you. You please archive the executions that you plan to reuse or that you think that they have values onto your workspace. And if you want, you can also back up your methods. There is a special tool for this, and the methods are just kept onto your workspace, are moved onto your workspace, and you can then reconstruct them from there. But this is less important. The most important part is to keep the execution list clean. Okay, so I was a bit in a hurry trying to manage the timing, Massimiliano. I hope I manage it. So there is a question and answer section anyway, where you can go again through all this information, which is actually a lot, I know. And I will now pass the floor to Giulio, so that he will show in practice what all this fluff that I presented is.
Let's start with this, let's say, small perspective from an early users on the system. So the idea here is to show you how to run a method that is already available and how to import one of yours. So for this demo, my idea is to work with some methods that I, let's say, implemented in order to, let's say, ease the narration, let's say. And you will see that they are more or less easy to envelop within the CCP and to make it run. So let's start by discussing a little bit on the interface. So as you can see here in the slide, it opened directly the method design CCP for the execution. On the left-hand side, as already Marco has mentioned, there is this list of different classes of methods that you can search by tag or by classes, let's say, that already contains a handful, let's say, of the methods that were already present on previous integration. Some of them are not here listed because they are not still shared, but they are already ported, let's say. And as you can see, for method, you have the version, the name, the one that uploaded the method, and some description with some time, let's say. So let's start with just looking at one of these methods and to see how it means, what does it mean to configure and execute a method that's already integrated within the CCP. So the first method that I would like to show you is this aside. It is a very simple method for simulating an epidemic spreading on top of a network. So we are not interested in exactly how the method works, but just to provide you a few insights, is a method that takes in as an input a network, a few parameters, and track and trace, let's say, a simulation in which each node in a network may transit from a susceptible status to an infected one given some, let's say, probabilities. As you can see, when I drag and drop or select by clicking on the green arrow here, the method, what happened is that I've been shown this schedule, basically this description of the method itself, in which we have the name of the method, a brief description, and a list of all the parameters that we will see are needed to be specified during the integration phase. So the runtime, this is basically the Docker image that will be used to build the network, to provide the network to the infrastructure. And then a few parameters. This is, let's say, method-wise parameters. So we have the beta, which is the infection probability in this case, the fraction of infected nodes at the start of the simulation, a code repository that we will see later on why I put this here, then a network file. Here we expect to have a link to a file that is in CSV format, and then a few other parameters, for instance, the number of iterations of the simulation, the fact that we would like to have as an output some visualization or other than the JSON file describing the simulation as a whole. And most importantly, we will come back to this later on, the annotation for execution. This basically expect to have a string that will be used basically to trace the execution even in your workspace in order to keep track of which are the execution you are referring to check the results and whatsoever. Moreover, as you can see here, you have some flags, for instance, this one that basically allow you to select or not to whether store automatically the results in the workspace, and then some other information that you can select or not to select which kind of output you would like to observe for this execution. So we would like to observe only the standard output, even the standard error, or only the result. So let's start to run this execution. So first of all, we can keep the standard value for the beta, the fraction of expectancies. These are not things that we are interested in. Annotation for execution, we can say, I don't know, webinar, just to remember that this was run within this webinar. And then I need a network file. In this case, I have already prepared within my workspace a CSV describing a network. What I can do here is just to get a shareable link, copy it, and then, put it in here as an input, okay? So basically what happens? What happens that this link will be used to fetch the data, and to use this fetch the data in order to instantiate the method. So I can leave all the other things as they are, and then click on the button execute. As you can see, I've been notified that the execution was accepted, and then in a few moments, the execution monitor will show also the execution for this SI method. You can see here it is, SI accepted with the days and time. And then basically TCP will take care of collecting the Docker image for Python 3.9.19, as I specified here, install all the requested, let's say, dependencies, and then execute the code and provide me with a link, either in the workspace or even here, a link to collect the data that he generated as a result. Okay, of course, this method has not been consolidated as already Marco suggested, so it will take a little bit more to, let's say, generate the results, because it will necessitate to, first of all, load, pull the Docker image, then execute the Docker image, instantiate and install all the requested software within the Docker image, and after everything has been installed, execute the code. As you can see here, basically the Docker image has been collected, and then some installation requests through pip and so on and so forth has been instantiated, till reaching, let's say, a status in which all the software is ready to be executed. And as you can see here, we are prompted with an information on what's happening. So what is, as you basically have this view as in a terminal, basically, in which you are saying this package has been installed, this other is are being collected, and so on and so forth. And also if there if there are errors or warnings, they will be reported because we selected also to report the standard error. So for instance, as you can see here, we have a few line in red that are warnings, basically the green that are the correct output, the correct execution of the method, and so on. So for instance, it was telling here you have a warning because we are running pip within the Docker as a root user. So and as you can see, the execution goes smoothly till the end. We can come back to this later on. In the meantime, just to stress something that Marco already told you, you can basically select, for instance, different languages. Here we have Python, R, Python, Python 3, or Julia, to generate code to basically execute this code also programmatically, so without the need of working within this visual interface. This could be very, very helpful because in this way, basically, you can mesh together results from different methods that are already available within the CCP. And this is of utmost importance, for instance, because we can have methods that are implemented in Python, other in Julia, other in C, or other languages, and this instead provides us a single wrapper, let's say, in order to be independent from the implementation through the execution. So basically, we can generate Python code to access this method, several methods, and chain this code in order to work with different methods at the time. Moreover, this direct link can be shared in order to allow a third party to access directly this page with a specification of the method without the fixed parameters. Okay, so basically, if you want to share this method with someone else, you can copy this link and provide these links to others. And the nice thing is that, for instance, this method can be used to enrich, and we strongly encourage you to do so, the catalog entry for the method that you integrate. So basically, let's assume that I integrate this method SI within the data catalog for the Big Data platform, Big Data AI. One thing that I can do is provide this direct link among the field of the method in the catalog in order to allow users that navigate the catalog to access directly the method in the CCP. Okay, as you can see here, the execution has ended, and we are provided with this link to an output zip folder. If you click on this, folder will be, let's say, downloaded, and as you can see, I will get in an output all the results. For instance, a plot for the diffusion trend observed in the model, a JSON file with all the iteration, and so on. The same result, since I have designed to automatically archive the outputs in my workspace, will be also available here. So if I come back to my workspace in the folder CCP, I will have a subfolder execution, in which under webinar, which is my tag for the execution, I will find exactly the output for the method that I run. Okay, so as you can see, everything is ecologically embedded within the research infrastructure, let's say. Still coming back to the links, as I told you before, this link is a link that allows you to link the method within the catalog or to share the method with others. These links, instead, is a little bit more, let's say, interesting from a replication study purposes. Basically, copying this link and sharing with some collaborator allow you to provide your collaborator with the same link to the page, but providing the method with already the parameters pre-configured. So basically, it's a way to allow others to rerun exactly the same experiment that you already run. So the idea is to allow a complete reproducibility of the experimentation. Okay. So
Giulio, sorry for interrupting. If you reopen your SI execution, yes,
here it is.
The execution has terminated. It still reports running. This is because it is not easy to push all the communications from a server to a browser. So from time to time, it can happen that some notifications are just overwritten. So just by clicking on the curly arrow, as Giulio did, you can update the status to the actual status. This is not a bug, it's just a syncing issue that can arise when you push messages to browsers from the server, okay? So it's a demonstration that everything is working correctly. It's not a bug, actually. Thank you. Sorry.
Perfect. Thanks, Marco. So, okay, this basically, as you can see, covers the instantiation phase of methods that are already integrated within the CCP. Now, just moving a little bit on how to integrate to import method. So in this other tab here, I've opened the method importer that is basically the tool that allows you to specify a new method and integrate it within the CCP. As you can see, you have the same set of categories specified on the left, and you have an empty sheet here to specify all the details, all the metadata required for your new method. So the title, the version, the description, some keywords, a category that basically will allow you to assign this method to one of these category present or to define a new one. Then the compatible infrastructure that, as Marco said, is nowadays is just one, so it is easy for you to select it. And then a few other tabs in which you have to specify the inputs, the outputs, and the scripting needed to deploy and to execute your code. Okay. Now, for sake of simplicity, today, what I will show you is not how to populate these fields one by one, but instead, I will show you how to use a pre-existing method, for instance, my own SI that you have already seen, in order to, let's say, modify it and to implement a new method. Okay. Basically, the only difference here is that since the method that I would like to integrate with you today is just a variant of an existing method, I will avoid basically to rewrite several stuff that they already written. That's the only thing. So drag and dropping the method within this right side of the workspace, I will be prompted by this alert that asks me to decide what to do. So either clone, edit, or derive. This is because I am the author of the method that I'm trying to, let's say, copy here. And if I'm not, what I can do is only derive the method. So I can just fork the method and, let's say, modify the fork. Okay. In this case, what I can do is just to edit, clone, or derive. Let's look at edit for the moment, and then we will clone to generate a new one. So through edit, I will be opened with the exact field populated by the method that I selected. So as you can see, I have the title, type, version, my description, the keyword that I selected that can be used to search the method, and the category. And finally, the compatible infrastructure. Then, as you can see, I have also a set of input that are the input required by the method. So the beta parameter that we have already seen before, which is called beta, which has its description, so infection probability. That is a string that is no format, just plain text. And the default value is this one, 0.02. The same happens, for instance, for infected, fraction of infected, or for the network in which I specify that I would like to have a path, online path, and URL basically to a file that contains the network. Okay. And the same for the other. So iteration is still string that has a default value of 100 and so on. Okay. There are some parameters that are important to specify. For instance, CCP image is, as you can see, a read-only parameter in which you have to specify which is the tag for the Docker image you would like to be pulled in order to execute your code. So for instance, here I specified a Python 3.19 image that basically is an image running an Ubuntu with this kind of version of Python already pre-installed. Okay, as I told before, this method is not a consolidated method. So what we will do, as we will see later on, is to basically install this Docker image, and then on top of this image, collect some code and make this code available. Okay. Another nice, let's say, input here that can be added by this blue button here is the CCP note. That is the annotation for execution that I already mentioned you during the execution. So is that tag that you can assign to execution in order to keep track of whether of the reason you are running that experiment, or in which context you are running that experiment. In my case, previously I set webinar in order to remember me that this was an execution of a design model tied to this webinar, for instance, right? And this basically is what is needed as an input for the method. Repository, in my case, is just another read-only parameter in which I specify the repository from which I want to collect the data to be run in my Docker image. As output here, I specify just the outputs and the JSON file, and then the important part here, the script to deploy and to run. So the first thing first, I decided to create a directory called SCP data output in order to store my result. Then I decided to clone my repository, and this syntax here basically states keep the value offered by the input variable repository and place it here, just placeholder, within a folder called execution. Then I move into execution and I install what is needed. So in particular, I install my library, which is ndlib from its repository. I install some requirements that are that has been collected within that are basically specified within the repository that I specified here, and then I collect a network through the path that I specified in this variable network here and save it as network.csv. After that, I exit from execution. Then to execute the code, I wrote this small, let's say, handle here. I enter in execution and then I run the script Python main.py. That is basically a script that we will see shortly has been defined as the unique script within the repository that is linked here in this variable. Okay, so basically what it does this script main.py. Basically, it takes all the input that I specified here among my variables, pass this to this main.py, parse them, and execute my libraries with that parameter as an input. Okay, this is probably something that most methods will not need. This is something that is needed from my library because, as you can guess, being a library that, let's say, exports several methods at a time, I need to have some proxy, let's say, to select the method, not only the parameters. Okay. After that, this gives me basically the execution of my code. I copy all the result in CCP data output, both the JSON and the PDF file for the images, and then I exit. And this basically is how the method it will be deployed and executed in CCP. Okay, this will be the code that are run respectively after having pulled the Docker image, and this one execute after everything is ready, so everything has been installed in order to execute the code that I want to be executed as a. Now, before integrating another method, let's give it a look at this main.py, just to provide you an idea of what you will need to do in order to make available a method programmatically, let's say. So this is the repository that I were getting and installing before in the deploy phase. The main.py is just a script that takes care of importing all the method that I need to read from the terminal, basically all the parameters that are needed for the method. So you can see, for instance, the beta parameter or whatsoever here are just, let's say, collected in a way that is conform to my libraries, to parse them with this function here, and then just to execute the model using how I would like to execute it in the library as a whole. So basically, these are code that is ndlib code, it's my library code, in order to execute everything. And finally, I save the results in some files, iteration JSON for the results that can be reused to be analyzed further, and in PDF, if the argument is true, the result, the visualization of the result. Okay, so basically, with this piece of code that can be simplified for simpler methods, I just tell the infrastructure, once everything is installed, how to execute the code and where and how to save the result. Okay. So let's try to create a new model, a new method. I just let's say create. Let me refresh the page. moment. I drag and drop my SI method here. I just clone it. And then I change a few information. So for instance, I will focus on an SIS method. So that is a similar method for epidemic still. It has only a single parameter different from the SI. It's easy to implement. I specify that it is an epidemic model, so to be categorized as such. And then here I have to add a new parameter because, as we can see in the documentation, I need not only a beta, but also a lambda parameter here. So basically, I can just go back, add a new parameter. We'll call it lambda. And then lambda, and I would say, for instance, the default will be 0.01, something like that. It's not important. Then I have to change a little bit my script, not the one for the deploy phase, but the one for the execute phase. In this case, I have to change the parameter that I pass to the model. So for instance, here I need to access the SIS model. And instead of having only the beta parameter, I will need also a lambda search. Right, okay. A lambda parameter. Okay, so basically, with these small changes, I just implemented the new method within the CCP engine. As you can see, I started from a method that was similar to mine, and then I modified only those things that needs to be changed for the execution, in particular, changing the parameters in this case. So now I can save it. And as you can see, if I refresh here, I will see the SIS method appearing within my list. One thing that you can notice is that the SI method is flagged as shared here, meaning that it is available to all the users of CCP. While for the moment, this is not shared, so this is available only to me. So if I come back to the method engine here and I refresh the page, I can see that SIS is here, it can be used. For instance, run SIS by just specify once again the only information that is missing, meaning the link to the network. Test. And then as you can see, I can execute it without any issue, but I will be the only one able to see that method, okay? So at the moment that the method is mature, that all the execution worked, that there are no issue with the code or whatsoever, the thing that you can do is to share the method with all the other that are accessing the infrastructure. So clicking on this button, the method will be freely available to the other researchers that are working on CCP. Of course, the suggestion here is to share the method when it has been consolidated, basically. So when you have already an image that is being already pre-configured with all the execution and so on and so forth. Of course, you can do it even without the consolidation, but it's not so, let's say, suggested to some extent, let's say. Okay, so as you can see, now the execution has been accepted and everything will run as before for the SI method, rather than now it is another model that leverages the same libraries, but doing something different, okay? So, Marco, should I mention some?
Yes, can you please switch back to the importing interface? I would just add one small thing.
Okay.
Giulio, can you please reshare the screen where you imported the method, please?
Yeah, here it is.
Fine. If you click on the pen there in the method, you see the blue pen, this is the equivalent of drag and dropping. So if you have issues with drag and drop, mostly that's exactly the same. I wanted just to tell the small difference between cloning and deriving and editing. editing a method means you are currently modifying exactly that method. So exactly that JSON file representing that method. So you can, for example, change the version or fix the description or add an input that you forgot, and the method will stay exactly the same. It has the same identity. Cloning a method actually creates, this is what Giulio used, creates a detached clone of what was the method in origin, and they don't keep any relation. This is meant exactly for the use case that Giulio was speaking about. So if you have something which has a lot of overlapping parameters or a lot of things in common with a method that you already defined, you can use clone and then just change, but they will be considered two different methods, both in terms of identity of the method itself, but also of functionality. Deriving is something different. Deriving is like cloning. It creates a new method, but it keeps in the metadata a reference to the method it is coming from. And you will see that also in the provenance information and also in the description of the methods once you use it and so on. This is because this is what you can do if you are not the author of a method, because you can say, okay, I'm cloned from this method, but I have to keep a reference to the method I was cloning from. Okay, this is just a small addition to what Giulio presented. Massimiliano, do we have a bit of time, or did we run out?
Let's see if we have some questions from the audience right now, some burning questions, or we can maybe show something else. So if okay, see one raise an hand. Marco Procaccini, please.
Hi all. Thanks for this presentation. Actually, I have a couple of questions about the infrastructure. The first one is about the Docker image. I would like to know if the infrastructure is compatible with a specific Docker image configuration, or is possible to execute any kind, let's say, any kind of Docker image. And another question is about the open data, open science. I would like to know if I can, for example, use data of another workspace, for example, another user that loaded the data for this method, for example. And if I can reuse this data, of course, if the user made the data shareable, let's say.
Okay, so first of all, yes, the first answer is yes, you can access any Docker image from any Docker registry that is publicly available. Currently, we don't support accessing images that are protected for which you will need credentials to pull them, okay? This is the hardware that the system is running on is Intel-based, so mostly the images have to be built for the standard 64-bit architectures, but this is normally the case. So it's the default. So you don't have to bother about that. And we have already tried with the Docker Hub. We have already tried with the self-hosted Docker registry. We have already tried with the registry of a partner that wanted to try its images from its hosted registry, and everything seems to work correctly. So there is no particular difficulty in this. The second question, I think it's just a matter of having access to the data. As Giulio has shown, he's just got a shareable link for his network file, for example, and he used that one. So as soon as you have access and you can download the data from the workspace inside your method, then you can use it. So it's up to who shares the data to provide links that can be followed. Another way of doing this could be to have the data inside the shared attachments of the VRE folder, for example, so that it is visible for your community, and then accessing it by performing an authentication of your code against the D4Science identity management and access the workspace from there with the context of your VLab. So there is a lot of possibility, and as soon as the data is available for you from an authorization point of view, then you can use it inside your code. There is no technical difficulty in this.
Good. Thank you. And another question was about the debugging. If there are some way to debug the code during while it's running, like for example breakpoints or step by step, an interactive way to debug my code directly during the execution on the infrastructure. I have to do it locally and then execute on the infrastructure.
This is very difficult to obtain when you execute remotely, because you are crossing networks, architectures, and you are entering into a Docker container which is not meant to be, let's say, usable in this way. So it is very hard. For example, it is not possible in the current solution to send the input to your shell. So what you see in the live status update is a bouncing of the standard out, the standard error to the web, and then pushing to your browser, but it is not actually access to a terminal inside the container. This is something we are currently working on, and we are planning to see how it is possible to do, but it is hard. The point is that actually all this idea is that you could run your code on top of your development environment, either embedded inside Docker if you already want to, or from your IDE. And once you commit the code to your repository, and then you can just build your image, your Docker image with the code frozen into it, and run it at a method. So we try to be as flexible as possible in order to shorten the step from your development environment, where you can do everything you usually do, including debugging, to the method once it is deployed to the CCP. Okay, so for example, as Giulio showed, if you keep your method not consolidated and you use to clone your code repository during the deploy phase with a git clone, as Giulio showed, this helps you in performing all the development and debugging locally, and then just committing, pushing, and rerunning the code, the method in the CCP, and using the new version.
Okay. Thank you again.
You're welcome.
So if there is no other question, maybe we have the last 5 minutes. So I invite you to write your question in the chat, raise your hand if you have them, of course. We still have 5 minutes. Maybe we could show how to execute a method from Jupyter Lab.
Yeah, this is something I wanted to show because it is very useful to understand maybe the connections among the different services and the tools that you have. So what I would like to do is to ask Giulio to copy and paste the execution link of the first method, the one that is publicly available, into the chat so that I can just grab it from there. And what I will try to do is to show that we can actually use that link to get back to the CCP inside the browser from the UI, and then we move ahead. So first of all, I will share my screen again.
While you share the screen, there is a question from Paolo Zicari in the chat, how to access the CCP. So as soon as this webinar closes, we will make it available in the SOBIC Data Lab on the infrastructure gateway. So you will be able to access it from sobicdata.d4science.org, then click SOBIC Data Lab, and you will find exactly this interface with the method imported and the method CCP that you're ready to use. But just, maybe, right after we close this webinar.
Okay, so you see my screen, right? Is it like that? Yes.
Yeah.
Okay. You see, I have a lot of methods, probably much more than Giulio's, because I am the author of many other methods. I have all those testing and methods and so on. So once you will get the access to the CCP, you will see that there are several categories of methods, and mostly the last three here contain also methods that have suitable defaults for all the parameters and are so immediately runnable. Okay, so if you want to try out, you can just choose one of those methods, check that they have all the defaults set, and you can run them. Now I have copied in my clipboard the link passed by Giulio. So I will paste it in here in my browser and just press enter. And what I should see is here exactly. So you see, I have Giulio, did you send me this link here? The link of the
you also have the link for the data in the chat. It's the only parameter that is missing. Yeah.
Okay. No.
Later.
Okay. If you send me the link that you see under the execution, I will get it already populated, because this was also okay. So this.
Okay. Here it is.
I can take the chance of describing. So Giulio sent me this link, which points to the instantiation of the method with its default. But of course, I don't have the non-defaulted parameters set. So I would have to provide my own data. Okay, so in this other link that Giulio sent me, and I will copy it again and put it here, is the one that comes from here, this link here, from the execution. Okay. So here the execution is shared. So I have exactly the same parameters that Giulio used for running his method. Okay, so I see them here, and I could, for example, change it, but I could just click on execute and rerun exactly the same execution that Giulio ran before. Okay, so I don't want to do this. I would like to do something even different. I will generate Jupyter Python code out of this execution. Okay, so I will click here and click this blue button, code generation. I get this file, CCP request 1 IPNB downloaded. Okay, now I already have okay, restarted the session. Went out. Let me restart. I already have a Jupyter Hub here, which I will have to rerun because my session ran out in the meanwhile. This takes a few seconds. Okay, here I am. So what I will do now is just drag and drop the file that I downloaded in here. And Jupyter has uploaded this file. Double clicking on it, I see this is a notebook which actually performs exactly the same execution that Giulio has shown us from the CCP interfaces directly. Okay, so there is already everything needed in order to run the code here. Insert the password in order to get a token. Okay. Sorry, what went wrong here? I probably misclicked my password, miswrote my password. Let me see. Okay. Demo effect at the end strikes again. Okay, now it's there. So I will run this third cell, which is actually the one that sends the request to the CCP in order to execute the method. This request here that is used is a REST API endpoint which conforms to the standard OGC processes API, so it is actually standardized. And once I have started the method with this request, I execute the last cell, which is actually a loop that polls for the status of the job that I just submitted. Okay, so I polls the CCP and says what is the current status of the execution of the job. So what you see here in the form of output lines is actually what happened to Giulio's execution in the execution monitor that we saw before on the CCP page, the changing of the status from accepted to running and then to successful, the production of the outputs and so on. This is exactly the same, but you will see it as output lines noted in this Jupyter notebook, because I'm doing exactly the same thing, but inside Jupyter. Okay, this will take a few seconds, as we saw before, and then it will converge. And if the code is the one that I remember correctly, yes, it will also download the output file and write it here inside the local file system of Jupyter in order for me to use it for something else. Okay? So I thought that this maybe would be just a nice conclusion for this webinar in order to see the ecological, I like the the word that you used, Giulio, the ecological aspect of the composition of all these services.
That's great. Yes, it's very, very. We also had the demo effect, of course, that everything went well, but it was just a wrong.
Yeah,
wrong
I brought the wrong password. Yes.
Exactly.
We already tested this approach not only in Jupyter, but we can do it in RStudio with R. We can do it in Julia. So we already have a lot of possibility. And if any, okay, this is important. If any of you wants to integrate this functionality of executing methods for the CCP from its code, and the code is not one among the ones that have already been implemented, just tell us and we will try to provide the generation tool for it.
Okay. So while the Jupyter notebooks is running, maybe we can ask if there is one just last questions before we close from the audience.
I can know, of course, the execution is here too, so I can see it also from here. Just
exactly.
This is exactly the same execution.
So this is the actually. So this is the execution that was launched from Jupyter that is accessible also in this interface, of course.
Okay. So the point is here that these are just different windows on top of the executions.
So it's taking some time.
Yes.
In the meanwhile, so if there is no other question from the audience, we have activated right now the CCP in the Big Data Lab. So, you know, we hope you enjoy the service, you try the service, and, you know, give us feedback if you can. Whatever you know, questions, of course, support. You have the usual support ticketing system. So we are here to help in case of any support is needed. And so let's see. No, there is no other question. So meanwhile, the execution is completed.
Yes, I don't see the outputs now, but I think I have the wrong layout of the.
Yeah, that's okay. So maybe Marco, just go to sobigdata.d4science.org to show where to find the CCP, and yeah.
Okay.
Not directly there. So suppose you are. Yeah. Exactly. Yes.
So Big Data Lab.
So in the Big Data Lab, you now have the importer that is active and the engine that are active. So you can already start to test to import your method and to execute the methods in the engine, if you like. And I think we are done. So thank you for, thank you, Marco. Thank you, Giulio. And thank you for everyone that attended this webinar. And I think we can close now.